Live lesson, Friday the 15th. Not Friday the 13th, thankfully for that. Square roots, baby, and others. Let's get started. These are called perfect squares. Perfect squares are the numbers that if you just do like 1 times 1, you get 1, and 2 times 2 is 4. 1, 4, 9, 16, 25. If you were to take the square roots of those numbers, you get the number that you originally started out with. So the square root of 64 is 8. The square root of 121 is 11. If you take the square root of a number that is not a perfect square, it's going to be an absolute train wreck. So let's see what we're talking about. Rational numbers can be written as a fraction. It almost looks like rational and fraction are the same or the same word, rather. They're not. They can be a repeating decimal. For example, 0.33333333 is a third. So 0.333 is a repeating decimal. And it also can be written as a fraction. It can be a terminating decimal, which means it stops. Or it can follow a pattern. So a repeating decimal again, like 3.3 repeating, can be written as a third. Okay. If I were to do something like 5.681. Okay, you learned way back in the day that if I wanted to, I can read that as 5 and 681 thousandths. So if I wanted to turn that into a fraction, I can write it out as 5 and 681 thousandths. Okay, what I mean by following a pattern is the same thing as repeating decimal. If I had something like 5.621621621 blah blah blah, that follows a pattern, which means it's repeating. Okay, rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. Stuff like that would be the square root of 11. It's not a perfect squared, so I can't take the perfect square root of it. Something like 5.83127195 blah 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 blah. No pattern, doesn't repeat, therefore it is not rational. Pi 3.14159 blah 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 goes on forever, has no pattern. Those are irrational. Irrational is an ugly mess. So circle each rational number. Well, let's start out with here and go counterclockwise or regular clockwise. Let's do that. 0.303003. No. It looks like it has a pattern, but it's not a pattern. Square root of 8. Is 8 a perfect square? No. So can you take the square root of it and get a nice answer? No. Rational numbers can be written as a fraction. Oh, look, you're written as a fraction. Rational numbers can be repeating decimals. Oh, look, you're repeating decimals. We learned from about 30 seconds ago that pi is irrational. This is probably the first tricky one. Can you take the square root of 16? Sure you can. Can you take the square root of 9? Sure you can. Oh, look, a fraction. So U is. However, can you take the square root of 2? No. Well, you can, but it's not going to be pretty. So those are our 3 options. All right. Probably will hear my 2-year-old daughter jumping up and down in the background because she's insane. In between what 2 integers does the square root live? Well, let's go back to the second slide. If I wanted to find the square root of 25, I know what it is. It's 5. If I wanted to find the square root of 36, I know what it is. It's 6. But what if I want to find the square root of 30? I don't know what the square root of 30 is, but I know it's in between 25 and 36. So my answer is going to be in between 5 and 6. So that takes me back to this guy. I don't know what the square root of 10 is. I don't. But I do know what the square root of 9 is. It's 3. And I do know what the square root of 16 is. It's 4. So the square root of 10 is going to live in between 3 and 4. Huh? Similarly, I don't know what the square root of 38 is, but I do know what the square root of 36 is. And I do know what the square root of 49 is. And the square root of 36 is 6. And the square root of 49 is 7. So the square root of 38 is going to live in between those. Closer to 6, but in between 6 and 7. Similarly, up here, the square root of 10 is closer to 3, because 10 is closer to 9 than it is to 16. And 38 is closer to 36 than it is to 49. Okay? Good old Pythagorean Theorem, the reason why square roots are important. If I wanted to find the missing sides of a right triangle, I would use the Pythagorean Theorem. Pythagorean Theorem states that a squared plus b squared equals c squared. C has to be the hypotenuse, the longest side. Okay, C is the hypotenuse, the longest side. So when I see a problem, when I see a problem like this, I know that I'm supposed to find the missing side of a right triangle. So if I'm finding the missing side of a right triangle, I write out a squared plus b squared equals c squared. C's got to be the longest side, and it's already labeled as such. A and B, it doesn't really matter, so I'll call you A and I'll call you B. So I do a little bit of math. 4 squared, a fun game, plus 6 squared equals c squared. What's 4 squared? 16. What's 6 squared? 36. And what does that equal? C squared. On the left side, I can add them up to get myself 52. 30 more than the age that Taylor Swift loves. Is C all by itself? No. What's in the way? That mean old squared. How do I get rid of it? Square root it. Well, if I square root the right, I have to square root the left. So we are going to ask Siri, what's the square root of 52? And Siri will say,
1 moment. The square root of 52 is approximately 7.2111.
So we'll say 7.2. Do I have any centimeters, inches? Nope, nothing like that. So my answer is 7.2. Okay. Gonna be a quick lesson. Find the missing side. What is that? Oh, it's a right triangle. Perhaps I should write out a squared plus b squared equals c squared. Perhaps. I have to call you C because you're the longest side. It doesn't matter which one's A and which one's B as long as the longest side is C. So when I plug this stuff into the formula, I have 8 squared because A is B. 8 is A. 8 is A. B is Y, so plus Y squared. And C is 12 squared. And then I do a little bit of math. 64 plus Y squared equals 144. Subtract 64 from both sides because y is not all by itself. Cross you out. Y squared equals 80. What's the square root of 80? Point something, 8.9 probably.
The square root of 80 is approximately 8.94427.
8.9. Now, the reason why I knew it was 8.9 is the square root of 81 is 9, and 80 is just a little bit smaller than 81. No inches, no centimeters, no nothing. Hey, Lexi, can you take that phone into another room? Because it's loud, loud, loud. You can be in here, but you got to turn the volume down. Okay, love you. Bye. Children. Oh boy. Can't live with them. Can't leave them abandoned in a parking lot. What's wrong, honey? The water's over there in the frozen thermos. Why don't you let it go over there and get it yourself? It's frozen. James to Sarah. James and Sarah, they want to go to each other's houses. Oh, it's a nice little perfect diagonal street. Living on a perfect little right triangular area. What a convenient problem. So it looks like I have myself a right triangle and looks like I'm going to write down the Pythagorean theorem. You like videos? Mm-hmm. Oh, does this even have videos on it? Yes, it does. Yes, it does. Let's go to the videos. There you go. Videos. All right. C is the longest side. It doesn't matter which one's A, which one's B, as long as the longest side is C. So I'm calling A 2, so 2 squared. I'm calling B 1.5, so 1.5 squared. And C is the longest side. 2 squared is 4. I think this is 2.25. I think I'm I went to say I'm scared, but I said I'm squared. What is 1.5 squared?
1.5 raised to the second power is 2.25.
That's right. Let's add these up. Is C all by itself? No. What's in the way? Squared. How do I get rid of squared? Square root it. And the square root of 6.25 is 2.5. I know that. Now I finally, for once, I finally have a unit of measure. This is a word problem. So if someone's like, how far is James' house to Sarah's house? You're not going to be like 2.5 equals C. No, you're going to say 2.5 miles. Make sure that if you are doing a word problem, you answer using, I don't know, words. 2 more problems, kiddos. Find the distance between 2 points. Well, I have myself a coordinate plane. And it's not like I could just take like a ruler and measure how long it is from that one point to the other point. But this is what I can do. I can turn this into a right triangle like so. I can count how many sides are on this guy here. So 1, 2, 3. So you're 3. That's going to be 1, 2, 3, 4. You're 4. And I'll call you C. Why? Because that distance just so happens to be the longest side of a right triangle. You can be A, you can be B, as long as the longest side is C. So I have 4 squared, a fun game, ha ha ha, plus 3 squared equals, I don't know, squared. 4 squared is 16. 3 squared is 9. That's going to equal C squared. 16 plus 9 is 25 equals C squared. Is C all by itself? No. What's in the way? Squared. How do I get rid of squared? Square root it. And the square root of 25 is 5. So what's the distance? The distance is going to be 5 units. Questions? You in the back? Questions? Okay. All right, last one. Find the distance between those 2 points. All right, well, same as the last guy. I'm going to draw myself the best darn triangle I can, and I'm actually pleased with that triangle. The length of that side right there is 1, 2, 3, 4, 5, 6. The length of this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's going to be the longest side, so I'll call it C. A squared plus B squared is going to equal C squared. Doesn't matter which one's A, doesn't matter which one's B, as long as the longest side is C. So A can be 10 and B can be 6. So 10 squared plus 6 squared equals C squared. 10 squared is a hundo. 6 squared is 36. C squared is, I don't know. But a hundo plus 36 is a hundo and 36. And that's going to equal C squared. Is C all by itself? No. What's in the way? Squared. How do I get rid of it? Square root it. I don't know what the square root of 136 is, but it's probably in between 11 and 12. What's the square root of 136?
The square root of 136 is approximately 11.6619.
So we'll say 11.7. All right, boys and girls, that should do it. This was everything from chapter 7? Not everything, but most of it, most of the good stuff. That should do it. Bye.